Hey class, this is going to be a short video on base numerals. This tends to be one of the toughest topics of the course, and it's just because we're so used to working with base 10 numbers. And rarely in math curriculums do you really see a whole lot of instruction on doing math and dealing with numbers in different bases. So I'm just going to walk through a few examples with you. All right, first example, write 37 base 6, but write it in base 10. So this is really not what we normally think of as the number 37 because it's telling us that it's in base 6. But let me just off to the side go over with you and remind you, what do we mean by numbers that are in our usual base 10? So let's think of the number 37 when it's really in base 10. Regardless of what base a number is in, then the place values in that number are basically representing powers of that base. So the number in what we know to be the ones place is really a number that's going to get multiplied by 10 to the 0 power. And as you move to the left with place values, then you increase the exponent with the power as the power of that base. So this number would be times 10 to the first. So that if we expand that out and say, all right, 3 times 10 to the first plus 7 times 10 to the 0 power, then 3 times 10 to the first is just 3 times 10. That's 30. 7 times 10 to the 0, well, anything to the 0 power is 1. So 7 times 1 is 7. And you see that, yes, that is the number 37 base 10 that we are typically familiar with. So let's do the same thing with our example back here, but realize it's in base 6. So that we're going to take the number 37 and that number in what we're used to calling the ones place is going to be multiplied by not 10, but by 6 to the 0 power because we're in base 6. The next number over, going to be multiplied by 6 to the first power. If you had another number over, you would multiply it by 6 to the second power and so forth. So that in order to figure out what the actual number is that in base 10 that 37 base 6 represents, we just expand it out. 3 times 6 to the first plus 7 times 6 to the 0 power. And 3 times 6 to the first is just 3 times 6. That's 18. 7 times 6 to the 0, anything to the 0 power is 1. So that's like 7 times 1, which is 7. And so 37 base 6 is actually the number 25 in base 10. Let's do another one. All right, write 25 base 4, but put it in base 10. So once again, I'm going to write the number 25. Since it's base 4, I know this is going to be multiplied by 4 to the 0 power. This is going to be multiplied by 4 to the first power. Expand it out. 2 times 4 to the first power plus 5 times 4 to the 0 power. And 2 times 4 is 8. 5 times 1, really, because 4 to the 0 power is 1. So 5 times 1 is 5. And so this represents the number 13 in the base 10 system. So 25 base 4 equals 13 base 10. Now, ones that are going to be a little bit harder, I think, are when we have to do the reverse. Take the number 387, which is assumed to be base 10, because if you don't see a little base number written in the subscript, then you assume base 10. So what we understand to be our regular number 387 in base 10, but now we want to write it as a base 12 number. What helps me at first is to remember what are the digits in a base 12 number. So we always start at 0, 1, 2, dot, dot, dot. But like, let's think of our base 10 system. Base 10 has the digits 0, 1, 2, all the way to 9. So when you get to the last number before you get to the base number, so 9, and then you would get to the 10, then that's how you know you stop. So with base 12, we would have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we would stop. But what in the world are we going to do for 10 and 11 since we don't have single digits? Well, that's where we're going to use A and B. So that the A is really representing a 10 and the B is really representing 11. All right. So what we can do here is we can take our base, in this case 12, and I like to think of the powers of 12. So we know that 12 to the 0 is 1, 12 to the first power is 12, 12 to the second power, meaning 12 times 12, is 144. 12 to the third power, which is really 12 times 12 times 12, so 12 times 12 times 12, is 1,728. As soon as you get to a number that's bigger than this number that you're trying to represent, you know you've got enough powers of 12 to do the problem. So a number, when the number is too high, like 1,728 is much bigger than 387, then we know we cannot use that. It's too big. But that means that we can use 12 to the second power because the 144 is lower than the 387. But what we need to figure out is how many times does 144 go into 387? So you could say, you could try in your calculator 144 times 2, that's 288. All right, that would work because 288 is still smaller than 387. You could try 144 times 3, which is 432. That is too big, bigger than 387. So what you know is that this number right here goes in twice into the 387. So we take our 387 and remember twice, so twice 144 was 288. Well, we're going to subtract and get the difference here. So 387 minus the 288, and we get 99. All right, so now we go down realizing that 144 is now done with. We go down to 12 and we ask ourselves the same thing. How many times would 12 go into 99? Well, you kind of go up the ladder. 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5. 12 times 6 is 72. 12 times 7 is 84. And 12 times 8 is 96. 96 is still smaller than 99. So what that means is 12 goes into 99 6 times. Oops, I'm sorry, 8 times. 8 times, which is 96. So all I got to do now is take 99 minus 96, and I realize that there's 3 left over. So now we're ready to write our answer. So there were 3 left over. So we know that, so be thinking about the place values as 12 to the second, 12 to the first, and 12 to the 0. We know that 12 to the second right here went in 2 times. We know that 12 to the first went in 8 times. And we know that 12 to the 0, which is 1, went in 3 times. This is a base 12 number. It represents the base 10 number, 387. It's easy to check these if you think about the way we did the first 2 examples. So that I would just take, and I'm going to come check it over here. So I would take 2 times 12 to the second power plus 8 times 12 to the first power plus 3 times 12 to the 0 power. And 2 times 12 squared, well, that's 2 times 144, so that's 288. 8 times 12 is the 96, and 3 times 1, which is 3. And if you add those up, 288 plus the 96 plus the 3, you would get your 387. Checks. And one more example. Let's write 257 in base 9. All right, so once again, I'm going to think of the digits in base 9. That's really just 0, 1, 2, dot, 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 all the way through an 8. And so what we need to think about now are the powers of 9. 9 to the 0 is 1. 9 to the first is 9. 9 to the second is 81. 9 to the third, which is 9 times 9 times 9, is 729. And 729 is bigger than the 257 that I'm trying to represent, so I know I don't need that. All righty, once again, we're asking ourselves how many times does 81 right here go into 257? Well, again, you can just do 81 times 1, 81 times 2, which is 162, 81 times 3, which is 243, and that's going to be the one that works, because if you do 81 times 4, you're going to get a number bigger than 257. So that means 9 to the second, which is the 81, goes into our number 3 times. Okay, but now we have to realize that we're trying to represent 257. So far, we've got 243 accounted for. So we just subtract there and do 257 minus the 243. And we realize that we have 14 left over. Well, 14 left over, that means 9's going to go into it one time. 2 times would be 18. That would be too much. So 9 goes into it one time, which is 9. And therefore, we have 5 left over. So 5 left over, which means here's how we're going to write our number in base 9. 3, 1, 5, base 9 is our answer. Check it. We're going to do 3 times 9 to the second, plus 1 times 9 to the first, plus 5 times 9 to the 0. And that means we would get 243 plus 9 plus 5. And that will then give us our 257. So I hope that's helpful for you. Again, I just think with a little bit of practice, just because it's unfamiliar to you, with a little bit of practice, I think you'll hopefully catch on to how to do these base numerals.